Please make sure you write the learning target in your notebook. Hi guys, today we're going to be going over 8.1.1, how can I describe the graph? We're going to be sketching graphs of polynomial functions. So please read the introduction, so press pause. It's really important that if you do not remember what a polynomial is, you can click on the word and you can read the definition and see what it means. So Math America Land Carnival Company wants to build a roller coaster. It's really important to know that part of the roller coaster will be underground, so you guys got to take that into consideration. We're going to start off with the first equation given and try using Desmos to graph it to see what you remember. So please go to desmos.com to graph that portion. So one of the things that I want you guys to notice is that is the equation, the first equation that is given, and this is the graph. We can also write that equation as this. You could see that it overlaps. And I want you to think about the connection between the equation and the graph. So please pause the video so that you can talk about that and write something down. Okay, thank you for pausing the video to analyze the connection between the equation and the graph, but you should have noticed that each factor is connected to each x-intercept. So x minus 0, the connection is the x-intercept at x equals 0 and x minus 2. If you set equal to 0, then you will solve for x and it gives you your second x-intercept. We're going to take the time to analyze this first equation. So this is going to be our first x-intercept. And if you look to the left, we have this portion. And I want you to think about it. Is it in the positive? Is it in the negative direction? So on this side, the values that are above it are in the positive direction. Now we're going to take a look at the middle section in between the x-intercepts. We know that it dips down between and then goes back up to the x-axis. And now we're going to look at the last x-intercept. And we can see that for this portion, this is where our x-intercept is at, and it is also in the positive direction. So for this one, we notice that both the right side and the left side of the x-intercepts, both sections are positive. Now my question is, what do you think would happen if we have a negative? So please pause the video so that you can predict what will happen if we add a negative. Okay, now let's see what happens if we add a negative. So we can see that this has been reflected over the x-axis, and I want you to take the time to analyze what happens to the left of the first x-intercept and to the right of the last x-intercept. So now we're going to analyze this. We notice that we still have the same x-intercepts. Now what happens to the left of the first x-intercept, and we notice that those values are going to be negative. Now, what happens between the x-intercepts? we know that it loops up and we're going to have some positive values. And then I want you to analyze the graph and see what happens to the left of the last x-intercept. We notice that those values are going to be negative. So now I want you to do the same thing. I want you to go to Desmos and graph that one, y equals quantity x minus 2 squared, and the third one. And I want you to think about the connections between the equation, the x-intercepts, and how you can modify this equation to find the equation of that roller coaster. Graphing the second equation, you can see that the parabola bounces off of the x-axis. Now here is the third equation. There are 3 factors and there are 3 x-intercepts. So you have one at x equals 0, x equals 2, and x equals 3. So take time to work with Desmos. Remember that it has to be very similar. It has to go beneath the x-axis because it's going to be underground. So please take time to work with Desmos to find an equation. So for this equation, I want you to notice that we have x equals 0, x equals 2, and x equals 3. So each factor corresponds to each x-intercept. Now let's analyze what is going on with the behavior of the graph before the first x-intercept and what kind of y values do we have. So on this side we have negative, but after the last x-intercept we notice that our y values are going to be positive. Now, if this has 3 x-intercepts, what family do you think it belongs to? So please pause the video to take time to think about what family it corresponds to. So thank you for taking the time. And this is going to be a cubic function. We have 3 x-intercepts, 3 linear factors. So the equation, the family that it belongs to is a cubic family. So I want you to take the time to think about the track of this roller coaster. And we know that we have x-intercept as 0, 2, and 3, which is something very similar to what we have. The only difference is that we need that bounce that we had here with the bounce touching the x-axis. So I want you guys to take a look at the roller coaster and the last equation, which is what I have on Desmos. I want you guys to see that it is very similar. The only difference is that at x equals 2, we need to make sure we have that bump. We have an x-intercept at 0, at 2, and at 3, but we need that bump, that bounce at 2. If we look at the previous equation, we know that if we square the factor, it gives us the bounce that we need. So let's try. That looks pretty close. So we do have x equals 0, x equals 2, and x equals 3. So this is the final equation that we wrote. So we know that we have this x-intercept, x equals 0. This one has a bounce, so we have two factors there, which corresponds with this. And then we have x equals 3. So x equals 0, x equals 2, and x equals 3. Here we have a bounce, and this bounce counts as 2, so we have a total of 4 x-intercepts. So let's analyze and see what happens before the first x-intercept. And we notice that our factors are going to be, our outputs are going to be positive values for our y values. And then after the last one, we notice that those y values are going to be positive as well.